Hello, my name is Jack, and I am a STEM instructor at Creative Encounters with Science conducted through the University of Guelph. In our last video, we reviewed how to identify an appropriate sample size for your science fair project, which we discussed in our last Science Fair Club meeting. If you missed the last video, click the link in the description or visit our website to learn more about our free virtual Science Fair Club. Today, we'll be discussing how to log your data once you start experimenting. Logging data isn't as simple as just writing it down. It's important to keep your journal organized and make sure you're recording the right information. First of all, it is necessary to write down all of the steps you took while conducting the experiment into your log booklet. If you were to give your log booklet to a friend, they should be able to recreate your experiment based off of the steps you included. Also, everything you observe while conducting your experiment should be written down, because it's harder to remember the small details later. Along with logging your data, you should also be evaluating your data as you collect it. You can do this by making predictions about what might happen next in your experiment based on your previous notes. Also, make sure to write down your thoughts about what you have observed so far. In addition to writing down the results of your experiment, taking videos or pictures are good ways to record your observations, because you can refer back to your recordings to add to your notes or even include in your presentation. This will be helpful to you when you look back on your experiment, because you might notice a trend or an outlier in your data. Put simply, an outlier is a piece of data that just doesn't fit with the rest. Having an outlier isn't a bad thing, but it could be a sign that you made a mistake somewhere in your experiment. Making notes can help you figure out where you may have gone wrong, and if you did make a mistake, they can remind you that the outlier is an incorrect piece of data which can be ignored. This will stop you from adding it into your presentation and help you explain why the outlier occurred. Once you've decided how you will measure your results, that is, which unit of measurement you will use, you have to stick with it. For example, you can't start off measuring in millimeters, then halfway through your experiment change to centimeters. Not only is this inconsistent, but you would also have to convert them all back to the same unit at the very end. Even worse, you could accidentally plot the wrong data in your graph. That being said, it is crucial that you choose the right unit of measurement at the beginning of your experiment. For example, if your experiment measured the weight and height of radish plants, it would not make sense to measure the plant's height in meters and measure their weight in kilograms, since the plants will not grow to the height of at least 1 meter and they will not weigh multiple kilograms. When evaluating those measurements, we would be dealing with very, very small numbers, which could be misleading. This could be avoided by using centimeters and grams instead. If you would prefer to use a computer instead of a notebook, a good place to keep all of your numerical data would be in a spreadsheet on Google Sheets. This is an excellent application which you can find online, and you can use it to make a graph based off of the data you have collected. Now that you've gotten all of these tips, you might be wondering, what if my data doesn't do what I think it will? If my results do not support my hypothesis, could I just reach into my spreadsheet and... No, you cannot adjust your results to fit with your hypothesis. It is absolutely okay if your experiment did not work the way you intended. Tampering with your results takes away from your science fair experience and what you learned about in your experiments, not to mention the fact that it is very unethical. Scientists have spent millions, nay, billions of dollars on experiments that were null, meaning that they did not find their expected results. Even if your hypothesis was incorrect, you have still accomplished a lot with your project. Your experiment has still discovered something new, even if you found out that your experimental design simply doesn't work. Null experiments can sometimes open up even more possibilities in the future than successful ones, like the Michelson-Morley experiment. Albert A. Michelson and Edward Morley's famous experiment actually disproved their hypothesis, which turned out to be a really good thing. Their results changed the way that scientists thought about the movement of light, and they even won a Nobel Prize. The Nobel Prize is an award given to people who have made great contributions to humankind. Even though their experiment failed, the results from it were still very valuable for the future of physics. Null experiments act as a launchpad for even more research and experimentation. So don't worry about whether or not your hypothesis ends up being true. Your experiment will provide valuable insight into your topic either way. But if your hypothesis ends up being disproved, and you still have time and resources before the day of the science fair, try to modify or add to your experiment to learn more about why your hypothesis was disproved. To do this, you can come up with another experimental design to retest your hypothesis, or even better, come up with a new hypothesis using what you have learned from your original experiment. If you have any questions about logging data and recording observations or any other component of your science fair project, please email us at ces.scifair@uoguelph.ca, and I or another member of our team will be happy to help you. This is the last video in a series of 4 short tutorials to help you with important steps in your science fair project. If you would like to review the scientific method, ethics and safety, or sample size, click the links in the description of this video. We hope you have learned a lot from these videos, and we will be building off what we have learned in our virtual Science Fair Club meetings, which take place every other Monday in the new year, starting on January 4th. Visit our website to sign up for this free virtual club on Zoom video chat, and follow our Instagram at CES Clubs to get frequent updates on all of our club initiatives. Creative Encounters with Science is a proud member of the Actua Network, and we would like to thank our parent company as well as all of their sponsors for making Science Fair Club possible. I hope you enjoyed this video, and thank you for watching.